Good afternoon, everyone. As BMK said, my name is Sam Barker, and I'm a principal software engineer with Red Hat, except today I'm not wearing my fedora. I'm here representing the Kroxylicious project, which none of you will have heard of. So what is Kroxylicious, other than being a big mouthful to say? We are a fully open source, Kafka protocol-aware proxy server. I say we're transparent because we don't alter the Kafka protocol. We don't interfere with what it's doing. We get out of the way and let it do what it does well. We provide full message fidelity through Kafka upgrades and things because we use the same serialization and deserialization stack as the Kafka brokers do. And that, as I'm sure the observant of you will notice, means we run on the JVM and we let Netty handle all the low-level networking cleverness. And how do we make that useful to you? We provide chains of composable filters to allow you to observe, transform, and act on messages. Don't worry about the diagram, it's just noise. The Kafka protocol is a binary protocol, and that's, well, a useful question that a lot of you would be asking is, why a new proxy server? What's wrong with the existing crop of them? Most of them have their heritage in HTTP, and that's a text-based protocol. And when you start dealing with binary blobs going through those protocols, life gets a bit complicated and a bit expensive. So that binary protocol that Kafka provides, it's a great design choice. It works very well, it's very efficient, but it doesn't play well with multi-stage pipelines because everybody's got to read the message, deserialize it, decide they care, do something with it, and serialize again. And if you can read the diagram, you'll notice that all those boxes, all those steps are roughly the same size. So we have just dwarfed our business logic with dealing with the accidental complexity of Kafka. So a sensible answer would be shift all this right to the broker. Well, we can't really do that because Kafka doesn't give us an API to do that on the broker. And the broker's not always the right home for this stuff. If you've got Kafka on a third party, random cloud provider with American government connections, you might not trust them to host your data and keep it secure. So you're definitely not going to give them your encryption material to do that. So Kroxylicious, as I said, is the protocol aware, which means we can infer things about what the messages that are passing through. Filters register interest in specific types of messages, either the request or the response to it, or all requests and all responses. And that means that if we know no one's interested in that message, we skip deserialization entirely and just ship that byte straight through. We will if we know someone's interested, we'll deserialize once at the start of the pipeline, and then reserialize once at the end of the pipeline. We're not inflating and deflating all the time, which leaves your filters to focus on your core business logic rather than the accidental complexity of interacting with Kafka. But all that is by way of background. That's not really what I'm trying to talk to you about. A couple of the use cases is what I really want to talk about. So everybody gets Kafka, or multi-tenant. We present a series of logical or virtual clusters in our parlance, all of which are hosted on a single, or one of many, Kafka clusters in the background. As far as clients are concerned, they are dealing with their own Kafka. It's unique to them. Everybody gets their own one. So imagine you're the platform team, and you want to provide Kafka to all your microservices, but you don't want to have to look after dozens of Kafka clusters, because they're expensive in terms of compute, resources, network transit, and because they come from this kind of pre-cloud world that made a very different set of design trade-offs to what we would make today for a cloud-native community, they involve lots of human interaction. So you don't really want to manage dozens of them, but everybody wants their own one, and everyone wants their own namespace. One that's a bit closer to my heart is speeding up the local developer loop. Imagine the ability to instantly provision a Kafka cluster for every developer. And then, other than changing the bootstrap URL, they don't have to care that they've got their own cluster. Everybody's got their own unique set of topics, and there's no collisions, no collisions on user groups or anything else. So to do that, we can have the proxy. It will rewrite all the messages transiting through it. All that's happening is each consumer is reading from a different broker. It's always connecting to my topic. And the broker on the right-hand side always has never heard of my topic. It's got something that's namespaced unique to that cluster. Where would you deploy that? Well, you'd keep it close to your Kafka cluster. And if we are dealing in TLS and we've got certificates around, we can use server name indication, and we can actually just do that with one host, one port name, one port on the firewall, and everything just connects and does it through DNS magic. If we're not dealing with certificates and all that sort of stuff, we expose one port per broker that we're trying to expose on the back end, and everybody connects their own thing. But we will rewrite those messages going through the proxy so that the clients just do all this automatically. That's what Kafka does anyway, right? I mentioned earlier about security. One of the other big filters we have is what we call topic encryption, or encryption at rest. It's a filter which transparently, if your topic matches, encrypts the message. It runs it through an encryption key and spits out gibberish as far as everybody's concerned. But why would you want that? Well, you work for a government organization or a financial services organization. They really are out to get you. You don't trust your hosting provider. It's outside of your security bubble. So you want to make sure the data is encrypted before it gets to them. Or you're just doing the right thing and applying layered security. It all works the same way. In this case, we'd actually want to host the proxy server near your app, so it stays inside your security environment, inside your trust bubble with your key material, and we only do that once. It could be running in a secure enclave somewhere or on one of IBM's shiny mainframes. There's all sorts of memory security problems there. Why not just do this in the client? Well, if you do it in a proxy server, you've got central and consistent applications so that everybody knows you've done it once and you've done it right. Ask your auditors if that's a good idea or not. If you don't have auditors to worry about, lucky you. But also, as other people mentioned, separation concerns applies at this level as well, right? The producer shouldn't care where that data is being consumed. It shouldn't matter to a producer running in a secure environment if that data is being consumed off somewhere else in an insecure environment. It's not its problem, right? That's handled elsewhere, externally dealt with before it goes out. Why not use disk encryption? That's solving a bit of a different problem. That's protecting the bytes once they've hit a disk and once they're in backups and storage and all that sort of stuff. But by mounting that disk onto the Kafka file system, you've automatically authorized access to it. So if anyone with access to your file system got access to your topic data. So this just encrypts it before it gets to the Kafka broker. The Kafka broker just sees bytes. How does that look in practice? Well, putting it together with the multi-tenant filter, we can see that we've got two different tenants. They each encrypt. They end up with different topic names, so we encrypt each tenant's topics with different encryption keys. But we could equally swap those two filters around. This goes back to those composable chains I was talking about. If we swap them around, all the topics are encrypted with the same key, but they're still distinct data on the broker. It all depends how you want to configure it and what your security model looks like. So if that sparked any thoughts about how a Kafka proxy could be useful to you, we'd love to hear from you and come help make that a reality. Thank you.